This is lecture 12. We're going to talk about generating random numbers using MATLAB. MATLAB uses this algorithm given here, this u sub I plus 1 equals k u sub I mod m, in order to generate random numbers from a uniform distribution. You do not have to know exactly how this works. I just wanted to actually just give you this formula so you see that there is some method behind just, when you put in the command into MATLAB. So basically, MATLAB seems to use that k equals 75, capital M equals 2 to the 31 minus 1. And here u sub I is called an initial value, which is called the seed. For our purposes, we just need to use this algorithm. We need to use the command that MATLAB gives. So there's a couple of different ways to use this. So here, if you just want one random number, now this is a random number from a uniform distribution. So remember the formula for a uniform distribution. Basically means uniform distribution over 0 and 1 means you're equally likely to pick any of the numbers between 0 and 1. So this is a continuous uniform distribution. This cannot be used if you want to draw from a normal distribution, from an exponential distribution, any other distribution. If you want a random number from another distribution, you have to use a different command. So this is just a single random number from a distribution, a uniform distribution over the interval 0 to 1. And it actually gives you, if you remember how you can do help rand or doc rand for a command, you can actually get examples. And so it says, what if you so if you do this, it'll tell you how to generate a number that's from a uniform distribution, but it might not be on the interval 0 to 1. Maybe you want A to B, where A is some number and B is a different number. You can do that using this command, and the dot command will help you figure that out. But if you just want one single number from a uniform distribution, you can just say rand, and it just gives you a draw from a uniform distribution. If you have like rand 10, then what this is going to give you is a 10 by 10 matrix with numbers that are drawn from a uniform distribution. So it's going to have entries that are drawn from some uniform distribution between 0 and 1. And if you have rand mn, then this is an m by n matrix. Again, all the entries are drawn from an uniform distribution. This will be what we're going to actually use some during in the next couple of slides. We actually may use this in some of our routines. Here, this is just another way of doing this exact same thing. You could do mn instead of m comma n, and then you have other versions of this. Okay, so some of the things that you might want to be aware of is you can actually set the seed. So here, the seed determines basically what I'm going to start with. So remember the seed being 57, if you set the seed, then it's going to always produce the same sequence of random numbers. So there's still going to be random numbers, but it's going to produce the same sequence because remember what MATLAB does is it uses that algorithm. So the random number is picked given what it was previously, so it produces the same set of random numbers. Here, rand state returns the current state of the uniform generator. If you set the state to 0, it sets it back to its initial state. If you set it to J, some like 5 or something, it sets it to its 5th state. Here, if you want to reset to a different state each time, so not reproduce, you can use this command. So, going back, examples of these can be found if you do the DOC space RAND in MATLAB. So to learn more about this, then and give examples of it, then go to MATLAB and actually look at the help topic on this, or the document on this. Okay, so now we want to visualize distributions in MATLAB. So remember this rand command would produce random numbers from a uniform distribution. So how do we see those random numbers? If we pick 10 random numbers, how do we actually visualize? I mean, obviously we can print them out, right? We can print out what the 10 random numbers are. But it would be nice to be able to look at the distributions in MATLAB. And when you look at the distributions in MATLAB, you can tell whether or not, if you just are given a set of data. So if you're given a set of data and you want to know what kind of distribution it looks like this data comes from, so you can plot the distribution of the data, and it might look like a uniform distribution. So a uniform distribution is going to look like it has equal probability of being any of the numbers between, A and B. Or it could look like a normal distribution where you have like the bell curve. So it's helpful to visualize what these distributions look like in MATLAB. One of the ways that you can actually, and so this hist y creates basically the distribution by, it takes the vector y. So here y is a vector, and what it does is it splits it up into 10 equally spaced containers and returns how many numbers are in each of those containers. So basically you're thinking about splitting up your interval. So you're splitting up your data, and you look from what the minimum number on your data is, what the maximum number on your data is. You split it up into 10 equally spaced containers, and then you figure out how many are in this first interval, the second interval, the third interval, how many are in each bucket. And that's what this n corresponds to, and we'll see an example of this in just a second. Here, if I don't want 10 equally spaced containers, maybe I want the distribution along the length of x. So here I want to know what my specific centers of those bins are. This one, it picks it by equally spacing it. What if I want to have it so that I have the middle of my first bin is at 0.1, the middle of my second bin is at 0.2, etc., etc. What if I want to know where the middle of my bin is? Then I can specify this. And here you can also give it just the number of bins. Let's say you don't want to specify the specific middle, but instead of 10 bins, you want 20, you want 100, you want 2. 1 is not going to give you much. But let's say you want that. And then this nx out gives you how many is in each bin, and also where those bins are, the frequency counts. And so this gives you the frequency counts in a bin. This gives you the location of the bin. And if you don't put an output argument, so notice this all has n equals n equals. If I just want to get a graph, I can just do hist of my y vector. Okay, so let's try creating a uniformly distributed random vector over 0, 1 with 10,000 elements. Okay, so how do we do this? I want it to be uniformly distributed, which means I'm going to use the command rand. It's already over 0, 1, so I can use the command rand. No problem, I don't have to modify it in any way. And I want 10,000 elements. So you remember, if we go back here, so you might be tempted to use this, rand 10,000, right? But what's that going to create? That's going to create a 10,000 by 10,000 matrix of uniformly distributed numbers. So we probably want 10,000 by 1, or 1 by 10,000, depending upon whether you want a row column or a vector, a row vector or column vector. So to create these 10,000 elements, I'm going to use rand 10,000, 1. Now let's visualize it. So how do you visualize it? Well, the easiest way of visualizing is just say hist of y. This is just going to plot out. Remember, what this is going to do is it's going to give me my bins. Here, the default is 10 bins. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bins. In this bin, I have a little over 1,000 elements in this bin. In this one, out of the 10,000 elements, I have slightly, well, maybe it's right at 1,000, etc., etc. So this really does look kind of like a uniform distribution, right? Which it should, because we're drawing from a uniform distribution. If it doesn't look like a uniform distribution, you probably have done something wrong. Okay, so what was actually plotted? When we did this, what was plotted? So to see what was plotted, we could have used this command nx out. So this n gives us how many are in each bin, and this x out is where are our bins centered? Where are our bins located? So this first one, our bin is located at 0.0501. Second one's centered at 0.15 here. So here we have 10 bins, equally spaced. Okay, so this is another way of plotting. Now what I've done is I've said I want to create my own bins. I want my bins to be centered at 0.1 to 0.9 in increments of 0.2. So I want my bins to be at 0.1, 0.3, 0.5, 0.7, 0.9. There's only 5 bins, and so this would be the number that's in each bin. Okay, so now what's wrong with this? Remember what the Linspace command does? Remember back when we did our little MATLAB tutorial? This Linspace command creates a vector between 0 and 1 that is equally spaced in 10 increments. This is not the same as telling the histogram that we want 10 equally spaced increments. So what this looks like, if you were just looking at this, it does not look like a uniform distribution because I've told it to space my first one at 0, my last one should be at 1, and everything else should be evenly spaced between. But remember, my interval starts at 0, so there's nothing less than 0. I've not picked anything less than 0. So of course this is going to be about half the size as this one. Here, 1, I've not picked any numbers greater than 1, right? So if I center it at 1, I don't have any numbers over here, so it's only plotting how many numbers I get between this value here and 1. So here this is going to be half the size. This does not look like a uniform distribution. I know I've done something wrong. So if I actually do create more of a uniform distribution here, I can apply it at 0.05, 0.15, 0.25, etc., etc. I know what my exact ones are. This looks very much like the first one we did with the 10 equally spaced elements. Okay, so now how do we use this RAN to simulate tossing a coin? You toss a coin, you get heads or tails. I want to simulate this somehow. How do I do that? Well, I know there's an equal probability of getting a heads and tails if we do it enough times, right? So if we do it enough times, there's about 1/2 probability of getting a heads, 1/2 probability of getting a tails. So we can have this random number. We can find a random number between 0 and 1. Remember, RAN just gives a random number drawn from a uniform distribution. And I can just say is that if that random number is less than 1/2, then I've drawn, let's say, heads. If the random number is greater than 1/2, so that's this else command, then I've drawn tails. So here this if else end command tells you if this is satisfied, then you set a equal to 0. Otherwise, you set a equal to 1. So this is the command to do that. So if my random number is less than 0.5, then I assume if I say a is equals 0 represents heads, then I assume I got a heads. If I say equal 1 equals tails, then if random number is between 0.5 and 1, then I get a tails. Okay, so what if I wanted to simulate 3 coins? I'm going to toss 3 coins back to back to back. How do I do that? Well, the first thing is let's do the toss. Well, the toss is I want 3 random numbers. So if I'm thinking about this idea, I want to pick the random number, right? And then I want to see if it's less than 0.5 or greater than 0.5. So here I've got my 3 random numbers. So here this is my first draw, my second draw, my third draw. And now I want to see which one of these are less than 0.5, and I'm going to set basically a equals 0 for those, and a equals 1 for the ones that are above 0.5. So this would be like I've drawn a heads, and this is like I've drawn a tails. So the find command actually finds everything that's in this vector toss that's less than 0.5. So it tells me what are the locations in which I had a number less than 0.5. I had a number less than 0.5 in my first entry and my second entry, but not my third entry. And if I wanted the number of times I got the heads, then I can just do the length of this. So I've got heads 2 times when 3 coins were tossed. Okay, so now we simulated tossing 3 coins. Let's do it 10 times. So how many do we get after we toss it 10 times, right? So this is the way to do this. remember this thing here, toss is where I toss a coin, right? This is what I did on the previous slide. So I toss my coin, and then I want the length of it. So here, how many heads did I get on that one toss? I'm going to set that as a component in this vector y. How many heads did I get? So toss less than 0.5 finds all the entries where I got a heads. Find says where are those entries and how many of them are there. So this tells me how many times I have tossed a heads on that trial. Now what I want to do is I want to do this 10 times. So I say I want to go from 1 to 10. So as I goes from 1 to 10, do this toss each time and keep track of how many heads I've got. So when I finish with this, on my first toss I got no heads. My second toss I got 3, 2, 2, 0, 2, 1, 1, 3, 0. So this is how many heads I got on each toss. Okay, so relational operators in MATLAB are quite helpful. Some of the relationship operators are less than or equal to, greater than or equal to. This stands for equal to, and this stands for not equal to. And these just really help figure out where you are in a set. So you can perform element by element comparisons. And so if this logical operator is true, then it sets the element to 1, and 0 basically means it's false. So for example, let x be this vector and y be this. So x greater than or equal to y. So what I'm doing is I'm comparing the numbers in x to the numbers in y, and I want to figure out whether or not this number is bigger than this number. So is 1 bigger than 0? Yes. So I set it. So x greater than y is going to be 1 here. Is 3 greater than or equal to 3? Yes. So I set a 1. Is 2 greater than or equal to 1? Yes. Is 5 greater than or equal to 6? No, so it's false. Is 1 greater than or equal to 2? No, so it's false. So when I did x greater than or equal to y, it figured out all those times where it was true and all the times where it was false. So you can't compare all the entries to the same number at the same time. So for example, if I do 2 times random number 1 through 8, and I want to see when is this less than or equal to 1, then it could do 1, 0, 1, 0, 1. So this number so here basically if this thing is bigger than a half, then it's bigger than 1, right? So here you can actually do this for your own, because since I'm setting the seed to 121, then I know what it is going to produce the same thing each time. So try this on your own. Try this in MATLAB and check and make sure that that's what it does. We can also see if something's in an interval. So if I want to know if something's between 2 and 5 and can be equal to 2, then I use this command. So I want to know x is greater than or equal to 2 and x is less than 5. So it returns a 1 if the number is in the set and a 0 if it's not. Okay, so that is used in this code here. This is a code, again, all these are from lecture notes by Ferries from Washington here. So this command does a draw of the numbers 1 through k with probability p1, p2, all the way up to pk. So p is a probability vector. Here I have a probability vector. What's the probability I'm going to draw? A 1, a 2, all the way up to a k. These all have to sum to 1. I need the sum of all possibilities to be 1. And then I want to draw n numbers. So n is how many numbers I want to draw. What it returns is it returns x. X is basically numbers 1 through k. And it's n numbers of these. So for example, if I roll a dice, I use this command, there's an equal likelihood that I'm going to roll a 1 through a 6. So here I'm setting all the probabilities the exact same. So probability, this 1 is just produces a vector of length 1 by 6 with all ones in it, and I multiply it by 1, 6. So I just get a vector of basically 1, 6, 1, 6, 1, 6. I put this vector in here, and I draw one number. So on the first time I draw a 2, I draw a 3, I draw a 6. So if I do two numbers and I want the sum of them, so again, here's my probability, and now I'm drawing two numbers. Here I get my two numbers drawn from my die, drawn from 1 to 6, and I want to sum those. I can use the sum command to sum them, and I get the sum is 5. So I do this 10 times. How do you do something 10 times? You use the for command. So for I goes 1 to 10, I basically take this sample of two numbers. It's going to give me different two numbers each time. I'm going to sum it up, and I'm going to set it as a component of my ith vector. So each time, what are my sum of my two numbers? So this is like if I was rolling a dice in Monopoly. Monopoly rolls dice. Okay, so if I roll dice in Monopoly, I might have gotten 6 on my first turn, 8 on the second, 3 on the third, 9, 7, etc., etc. Okay, so next time we're going to talk about law of large numbers and normal distributions.